Okay, I would like to welcome you on today's Backend Meetup. Today's Backend Meetup is a little bit different than we used to do because we have two external speakers from Pipedrive and Apify, and this is the first time we host a Backend Meetup with also external speakers. So today, you can be looking forward for speakers from three different companies, starting with Maca from Apify. He will be speaking about how they are monitoring traffic in Apify. The second will be Jindrich from STRV, speaking about GraphQL challenges, and he will also give you some tips how to handle the start of the project in GraphQL. Then we will have about 10 minutes pause to refill a beer or eat something. And then we will continue with another speaker, Rostislav Klein from Pipedrive. He will be speaking about their experience with integration of Facebook Messenger API at Pipedrive. And the last speaker will be Erhart from STRV, and he will be talking about scaffolding Node.js applications. And if there will be some time left, he will show you a little bit of live coding of how to use one nice tool to kickstart your project in Node.js. I hope you will enjoy it, and now I would like to welcome the first speaker, Maca.
Okay, so let's start. Welcome. My name is Matthew, and I'm coming from Apify, and we'll be talking on traffic monitoring today. So first of all, what is Apify? We are a web scraping and web automation company. So basically, we build a platform which helps you to automate any workflow you might have on the web. So just to give you an example, imagine you have your favorite supermarket that sells your favorite mozzarella, and you would like to buy it when it is discounted. So you can go to the shop every day and check, or you can check online, or you can automate this, have a bot which checks this on your behalf and notifies you when it's the time to buy. Or maybe you would like to automate downloading some videos and analyzing some content, or maybe unsubscribing from services that you no longer use. So in the center of all of this is something we call actors. And basically, actor is a job which runs in the cloud and does these things for you. So it's like a small program or a small bot. And they come in three flavors. The first one is off the shelf. So for example, you want to scrape Instagram, which means get the data from Instagram. And you grab the solution, run it, and here are your posts from Instagram or whatever they post on Instagram. Or you build your own, and we give you some tooling for that, like some SDK, etc. Or if you have like very custom use case, you can reach out to us, and then custom things happen. So those are kind of three avenues how these actors come to life. And originally, when we started about 5-6 years ago, we were kind of concentrating on the crawling use case. So basically crawling the website and getting some basic data from the website. And from the billing point of view, back then, you would have paid by page scraped. So for every page you visit, you pay whatever, 2 cents. And this is very neat, it's very kind of simple to understand, but it's quite limited. Imagine if you don't have like scraping use case. Maybe you want to automate something, like maybe you want to automate uploading files to Dropbox. So we changed the billing, and instead of paying per page, now you paid per unit of compute. So we made it more general. So basically, you run your actors, your jobs, and basically you pay for the time they run, for the compute they consume. So now this is much more general, which is great, but it does come with one big catch, which you might think about, and it's the videos. because videos are big. And if somebody is downloading videos, or maybe even worse, if somebody is downloading torrents and they are paying for a unit of compute, it does not consume that much of compute, right? But it does consume lots and lots of internet traffic. And it's costly because back then we would have paid for the traffic. So we could easily lose, in torrents example, like thousands of dollars in an hour when somebody abused the platform. And also it's not fair because if one of you does heavy compute job, they pay a lot, but if another person just downloads like big stuff, they don't pay that much. So that was the central problem we had to solve. And at the beginning, it wasn't that big of an issue, but at the scale we've been operating recently, which is like millions, tens of millions of jobs monthly and hundreds of terabytes of traffic, it does really make a difference if you do it properly or no. So to make this billing fair, we decided and changed the system, so you need to pay for the resources you actually consume. So in a similar way, for example, AWS does it. So the three main resources are compute, traffic, and storage. And further on, I will talk mostly about the traffic, which is kind of the centerpiece of this talk. So I need to warn you, to explain this further, I need to show you an example to illustrate how the platform works from the technical point of view. So imagine that you have children, and some of you might have children, and they like stuff, and they like to play games and watch videos, and they subscribe you to all kinds of services, Fortnite and Netflix and so on. And then suddenly you realize you are paying loads and loads of money for these services that you kind of don't use. So you need to fix it. And Truebill is a company we partnered with, and they're a fintech startup. And one of the things they do is they can actually go through your internet banking, see for which online services you pay, and then they have this app, and they show you the services you're subscribed to, and then you can unsubscribe with a single click. And that unsubscription part with a single click, so the whole backend, that's Apify handling the backend and handling the unsubscription workflows. So how that works? There are a couple of challenges to this. So the first one is that unsubscription is quite hard. I mean, there is no API for unsubscription. Like services don't want you to unsubscribe. So you can't just hit an endpoint and voila. So what you need is like something automated, something more powerful. You really need like a virtual browser, which is emulating the user as closely as possible. So you can actually unsubscribe from the services because there are forms to fill, a couple of steps, sometimes there is authentication, etc., etc. So from the technical point of view, it looks something like this. And I will be using these diagrams quite a bit. So I'll take my time just to explain what we see here. So the dashed line is the boundary between the external world and its internal. And internal is basically our cloud ecosystem, so our platform, which runs on AWS. And outside, you see the service we are subscribing from, so that's like public internet, the Earth. And on the inside, you see the actor job, which runs the browser, is a container running in the cloud based on Node.js, and is emulating the user. So, okay, so you can unsubscribe, but how do you know it's actually like done? You also need to store some metadata or some results or some responses. And we store this on Amazon S3, and you access it via API server. So, like very naively, the actor job can just access the API server via public internet. So it can hit the api.apify.com, but then this kind of goes out of the ecosystem and back again, which is redundant because they run in the same cloud. So that's why we actually have some, we use a library called hproxy or hproxy, I'm not sure how to pronounce it, which does the internal routing. So you can just hit the IP address of the actual API server and store anything on S3. And this API server is used quite a bit by the actors. So then, okay, now the job can unsubscribe, but how do you run the job? How do you actually run the actor? You want to trigger it somehow from your computer or from the app when you click something. So this is again possible using the API server, so it's very similar. And now you just hit the API server from the outside. And API server is just like simple Express.js server with REST API. And then when it is done, the data kind of flows back to you via that Amazon S3. So now you can run the service, run the actor from the outside. It can emulate the user. But now we come to the kind of central challenge, and that is that the services actually don't like you. They don't like you to unsubscribe. They would like you to stay. And there are two main challenges to overcome. So the first one is geolocation. If you have a service in the US, and then suddenly your actor, your job would be automatically trying to unsubscribe from France, and if it doesn't succeed, then from, I don't know, UK, it's kind of suspicious. So the location does matter. Also, the services collect a lot of information about you, like some metadata. It's called fingerprinting, like which browser you use, how fast the responses are, what header you use, what you click, how fast. And based on this, they are trying to assess if you are a human or not. So you need to look as legitimate human, otherwise they just block you. So to fix this challenge, you need proxy servers. And proxies are servers which sit in between you and the service you are subscribing from, and all the traffic flows through them. So in our platform, it would look something like this. We have Apify proxy server, which is a container running in, on Kubernetes, so it can be replicated, and it then in turn can connect to any external proxy providers, and there is a lot of those which connect to the service, and kind of the traffic flows along the arrows. So this proxy technology is actually, or this proxy server is actually quite interesting. So I would just like to take my time here to show you kind of the four main things it needs to be able to do a good job. So the first one is that different use cases require different kind of proxies. And roughly speaking, they are either these big machines sitting in data centers that are quite reliable and quite cheap, but you don't have data center in every US state or in every country in the world. And also they are easily blocked because they don't move around. On the other hand, there are these residential proxies, which are small devices, not reliable, can be quite expensive to use, die often, but they move around and there is a lot of them. It can be smartphones, laptops, anything. And these are very hard to block. So what you really need is residential proxy to look as a legitimate user coming from the legitimate geographical location. Second thing, which the proxy server needs to do, is to actually rotate the external proxies. So you can't connect from the same IP over and over and over again, because that's not what legitimate user would do, kind of connect from the same computer very quickly in a short period of time. So we need to rotate the containers, the proxies, maybe in a round-robin fashion. So all this one will come first now. The third one, which is quite nice, is that you want to be in charge of your security, of the TLS, which is the protocol for encryption. So to do this, you can use the Node.js package proxy chain, which we developed because there was no other solution. On Linux, there is something called Squid, which helps you to kind of open the TCP tunnel between you and the final like service you are targeting. And then you can run anything which runs on the TCP, so for example, HTTP, but also SSH, FTP, whatever. And also you are in charge of your own security, which is very important when you are accessing HTTPS websites. And the final thing, which kind of comes for free, is that you can connect to the proxy server from anywhere. So you can also connect externally, right? There is nothing preventing you from doing so. So you don't have to connect from the job itself, from the actor which runs on the platform, but you can connect from your computer. You can set Chrome or Mozilla to use this proxy server. Just maybe piece of advice, don't download videos or torrents because it gets costly to do it this way for you. Okay, so back to the unsubscribing. The challenges we've covered are that there is no simple API, so you need something, some actor which emulates user and unsubscribe you. You need to trigger it from the outside, which you can do using the API server. And also the service will likely try to block us, so you really need proxies. And the final challenge is that unsubscribing needs to be fast. Because as I said before, a user is clicking something on their phone and they want unsubscribing to be instant. And connecting via API server is okay-ish. It's not super slow, but it still takes a couple of seconds because the containers need to start, the job needs to start. Also, it loads this virtual browser, which is actually quite slow part. So the feedback is not like super fast. You need something like much faster, right? So in this case, what we did is that you actually run the actors non-stop, like 24/7. And then when user wants to unsubscribe, there is just new request coming, oh, unsubscribe me, but everything is ready. The virtual browser is ready, the container is running, so it can be done rapidly. So technically speaking, what I illustrated before, kind of the slow path, is the black one on the right, which takes a couple of seconds. And the fast part is on the left. And we build a service, again, containerized in Kubernetes and Node.js, called conductor. And it can receive the requests from the outside, and they're forwarded to the actor running nonstop. So the unsubscription can be very fast. Technically, this piece is also quite interesting because it actually routes traffic in 2 steps. So the conductor first routes traffic to the container, to the kind of a machine, which is like a worker server running Node HTTP proxy library, which is open source. And then there is second step, which actually routes the traffic to the relevant actor job. So now we have the same as before with the changes in the bold. So the containers, the actors are running nonstop, and you connect via conductor when you want the unsubscription to be really instant. So the final system looks something like this, and I omitted a couple of details. And it is a lot of arrows. I mean, each arrow on this diagram represents the flow of data or flow of traffic. And traffic also means costs, right? And since we run on AWS, we, in the end, pay the AWS pricing, and it can get pretty complicated. Like, for example, data going to the AWS are for free, but going out or not, and it depends if it is to the internet or AWS account or different region. So we need to track this with quite high level of granularity. So we need to know where the traffic is going, if internet, AWS, and which region. We also need to know which traffic goes in and out. And also, since we want fair billing, we also need to know which user actually is responsible for the traffic, so it can be built to their account. So at the end, we would like our kind of stats that we use for billing to look something like this. And there is a date, the second field, which is like on which date it was generated. Then this traffic type, which is if it was AWS, internet, which region, etc. Service, which actually means through which of our services the traffic flows. User ID, so we are fair. And also then how much bytes were actually transferred in or out. And to be able to have statistics in this form, we need to solve 3 things. So the first one, which is actually quite interesting one, is to know where the user is. So we can know if they are connecting from the outside internet or from different AWS account, etc. And the way we solve this is to use the user IP and AWS IP range. So going a bit more into detail, when you hit this URL, the HTTPS, etc., you can actually get all the IP ranges of all the IPs of Amazon, of AWS. And this is public, and it is the same for everyone. And in each record, maybe it's too small, but there is IP prefix, which is IP with / and number, and then there is the region, like US East 1 or North East 2, etc. So this prefix looks something like this. So it is first IP, and then a number after a /. So when written in binary, so when the IP, the first part, is written in binary, then you take 22, which is the second part, first bits, and that is kind of the range. And you can then put anything for the X, and it would still be in this range. So taking this from the data we got from Amazon, we build a prefix tree. So this is probably one of my favorite algorithms we use in Apify. So basically, here you see 3 IPs, like or IP ranges, 110, 111, 100, and you kind of suspend them from the top to create this tree. And then when a new user comes and you want to know if, like, where they are connecting from, you just take their IP, and if the IP starts with 110, you know it is in the tree, and you know which region it is because you stored it at the bottom of the tree. Or if they are connecting from somewhere else and their IP starts with 010, you know they are not part of the tree and they are connecting from the public internet. So this is how we know where the user is connecting from, where the traffic goes from. The second thing we need to know is, or we need to solve, is where do we actually measure the traffic? I mean, historically, we messed this up a bit, and then the stats just did not make sense, and now they do, which is great. And originally, we tracked the total traffic at the actor. But as you see, it's not all the arrows, right? So then we added tracking at the Apify proxy, then conductor, and then the API. And maybe some of you might have spotted that some of the arrows, these ones, were actually counted twice, which does not make sense. So this is kind of by design or historically. And what we do is we take the total traffic from the actor on the top left, then we subtract the internal traffic from conductor, proxy, and API. So those are the red arrows on the top right. And then if you subtract those, you get just the external traffic going from the actor to the public internet. So, okay, this is where we do the measuring. And the final challenge is to actually do the measuring and to have it real time. So we know exactly what's going on in the system and to have it persistent in case of system failures, etc. So the way we designed this is to have a kind of a two-step process. The first one is that at all the services, we buffer the updates in the memory. And in the code, this is actually taken from our code base, just simplified. We listen to the Node.js events on sockets. And when such events happen, such as closed event here, we take the statistics like the bytes read and bytes written from the socket, and we update some statistics in memory. So we do this buffering. And just to emphasize, the user ID here, we do know which user is generating this traffic because like vast majority of the requests are actually authenticated, like everywhere in the system, so we can get it from the token. So we can attribute it to the correct user. One funny thing about this is that, for example, the requests to the proxy, there is like one request coming from the inside, but it actually generates like two pieces of traffic. There is traffic on the internal side, and then there's traffic on the external side. And then there are bytes read and written, but they kind of swap on the other side. So if you are not careful, your data is gibberish. And also, it doesn't help that some of the fields, like on the requests, are labeled TX and RX, so it's quite hard to reason about. But finally, we got it right. So this is the measuring and in-memory updating. And then the very final part, which is actually the easy one, is just to regularly flush the data to the database. So we use Mongo, and every 5 to 10 seconds, you take whatever has accumulated in the memory, and you flush it there for persistent storage. So just to recap, we started with a system where we charged users per crawled page, and we transform it over the years to a system where you can charge the traffic attributed to the users. And also, very importantly, once you have this, you can also map it to our AWS costs. So you can do the cross-check and see if something weird is or is not happening in your system. So this is end of the presentation. Thank you. Happy to hear the question.
Should I screen?
Should he screen?
You
You can try or come here.
So measuring all the traffic, and that it's also measuring all the traffic. What is sort of the error rate that you have, or is it like, does it line up? Like, does it,
So-
does it basically show the same data as you're measuring?
Yes, well, same trends. Sometimes we are off by some factor, but like the trends are the same. But it took time because even if you have like a very small error somewhere, then the graphs totally don't make sense. So now it does. Okay, so I think we can go on. Thank you.
Thank you. Okay, so the next speaker is Jindrich Maca from STRV, and give him a second while I will connect his computer. And he will be speaking about the GraphQL challenges.
Okay, nice. Hello, everybody. Let's start this. Okay, so when I say sorry, little technical difficulties. Okay, got it. So, when I say GraphQL, you go Hive. No? Okay. I thought that GraphQL is really popular nowadays, so let's talk a little bit about it. Okay, so everybody go on the Hive train and let's go. So, GraphQL challenges. That's the topic. First, what is GraphQL and where it is used? You can notice that there's missing is because I forgot the field for property in my request, so that's GraphQL joke. Okay, anyway, GraphQL. What is it? It's design and query language for APIs. It's strongly typed language. It's application protocol agnostic that will come handy later. And basically how it works is first you define your schema for your data, then you can ask custom API queries, really easy. Where it is used, that's the really interesting part. You can, of course, design your new application APIs, but you, maybe more common or more like propagated use case is to use it as some API integrator or some gateway. And for me, a really interesting use is also Hello? Okay, it's also a connection layer for application logic. For example, Gatsby, really popular there, or somebody thought of connecting like GraphQL is statically typed, Postgres is statically typed. Let's put them together automatically, and you have like Hasura or, for example, FaunaDB also uses GraphQL schema, and many others. So pretty much range of use cases. Here at STRV, we use it often as our application API, also some integrator and gateway, and maybe in the near future some connection layer. We'll see. Okay, and just one basic example. So we are on the same page. Here's the query. Basically, I have some schema. I say what I want. I post it through some protocol, usually HTTP on the web, and I get data back in. Got it. Okay. So one note here. This isn't like completely numeric idea. It arises from the reflection of needs of developers that wanted something that helps them communicate with servers. So, one more thing to be on the same page. It isn't something completely new, but the architecture is based on well-known principles. So I guess everybody knows view model control scheme. So it kind of copies the schema like we have the view and we have our GraphQL schema that parse and validates our queries through some middleware. Then we have some controllers in the GraphQL called resolvers, and they fetch our data for some data sources. Two things that are not visible here. The data gets validated to the way there, but also to the way back. So the GraphQL assures that the data, not only that we can request only the things that are defined in the schema, but also that we return the things that the user asked for specifically. So that's a really important thing. And one more thing that's not visible there, we will get to that later. You can actually ask multiple queries in one request because it's not bind to the protocol itself, so you can combine things together. By the way, we won't avoid comparison with the REST API design. So just to be clear, you can do basically everything same in the REST. You can also validate your data back on the way to the user, but in GraphQL it's like all built in. Okay, and now for the challenges. A little bit of disclaimer. I really like GraphQL. I really like to use it. But challenges, we will focus a little bit more on the cons than the pros. But it's, let's say, for sake that everybody who wants to engage with the GraphQL knows about it and can enjoy all the pros. Okay. Let me take you on a journey when we want to build, design and build new GraphQL API, and how do we proceed, and where and what challenges arise. Okay, so first step is obviously designing your schema. As I was saying, GraphQL works that you design your schema and you ask queries. So designing your schema. Of course, you will follow good practices. Same with the rest. There are always good practices. So you want to be minimalistic. Don't overexpose everything at once because it can change in the future. So if you don't need it now, don't expose it. Be strict. Try to make everything required. You can always make it optional later, but making things required backwards is kind of hard. So all well-known good practices, but some more things. You are now in trickle type ecosystem, so you want to be exact. When there's when you are returning number, you want to return number, not a string. And also, you want one interesting thing, you want to count on future changes and extensions. The extension part is really important. For example, even if you are returning like single value, it might be a good idea to like wrap it up into some object type with one single property, because you can easily extend it later. But changing that type from the single value to the some object type is more difficult. So that's some good things to know when you design in the strictly typed systems. And also you are in schema now, because it's in the name. So one thing to be cautious about, that recursion is possible. So when you have user and user has some friends, those friends are also users, they can have some friends, and somebody can ask you like 3 ways into the deep for the friends of the friends of the friends, and you need to be able to respond to that. And also, when we are in the graph schema, it's good to think of different types of pagination, for example, cursor-based, or like nodes and edges, not only single limits and offsets. So, some things that you might think of when you design your schema, and usually, or maybe you don't think about them in your, when you designing some different now, when you design your schema and you are happy with it, let's serve it to our clients. Okay, but there are also some challenges. First thing is that one query might combine multiple data sources, and the might keyword is really like important here, because what it leads to are some distributed served requests when you can ask for one thing in different ways, and one time you don't ask for that field and one time you does. But that field is connected to some join into the database. So you now need to think about what it means for your performance. And you do the classical REST API request, you ask for everything, so you know you want to join that, or process your response and return it. Now you can ask only for something, and now there's the question, is the join necessary, you know, or is it? So you need to think about those things, and it gets even more complicated, as I said, because now single, like for example, HTTP request might contain multiple queries at once. So I can ask for user, but I can ask for 2 users or 3 users and their friends and so on. So now maybe they have same friends, and so my request overlap with the data. They share some data in the single request. So if I do it like in the REST APIs, I always get everything. I would need to get the same data multiple times in single request, which is not always like optimal. So, and the most important thing maybe to realize is that you are really like usually not in control of your potential queries. Like, yeah, when you developing some closed API and you closely collaborating with the front-end team, you know, you can like communicate what queries they will be asking. But when you work on some bigger applications or public APIs, you don't know. Anybody can ask different combinations of those things, and you should be able to respond in like reasonable time. So, what does it mean for performance and optimization? You know, you need to think about some clever ways how to combine your data sources. Let's say the first example with the join, you can always look what the user asks in the query and say, if the field is contained, I do the join. If it's not, I won't. You know, like query builder, easy thing, for example, in SQL. If you have, for example, MongoDB, you can store data accordingly, so you have it like on the hand when the user asks for it, and you can filter it out. The second problem, like the duplication of the same data for one single query, it's a little bit more complicated. Usually it's solved with something like data loaders, when you, for single request, you memcache the data by their unique identification, like some ID. And when you ask for it a couple times in the single query, you can, second time, third time, you can get it from the memcache. But you don't, you usually don't keep that cache for the next request because it can be something like different, so you flash it. But for the single request, you can do it like this. And now for the more interesting like subjects, because you usually when you have some queries that are not optimal, you think about caching, right? So how do you do caching when your queries can change and can be different for a single request, but ask for same data? For example, I have two almost same queries, only one field is different, you know, so how do I cache that? Well, you usually go about caching the query based on the field or some other stuff. For example, if the field is like taken from completely different service, it's maybe like good to cache that single field for to some Redis or somewhere. And also, even more fun topic here is throttling. So, for example, you don't want to hit when you have REST API and you are hitting it pretty hard, you can tell user, okay, slow down, wait a couple of seconds. But when you're hitting the GraphQL query and you know that one field that is really like expensive to take, it can be there, not need to. So how do I do about this? Again, you need to think about it in terms of field. What is like costly, or what could I do about it? And do I throttle like whole request, or do I like only do part of the data that should be throttled and so on? So it's some these are some things you need to be aware when you are building your schema. But again, be careful about premature optimization. Like if usually you think about those later in the development when you hit some performance problems, but it's good to know maybe to be prepared for these scenarios. So, okay, so now we have our schema and we serve our request. What's next? Well, we have our happy path, right? So now we handle errors. Yeah, so there's the thing about that the GraphQL is not application protocol agnostic. So we saw example with HTTP, but you can as well serve it through WebSockets. And now, like, how do you respond with HTTP error through WebSockets? You know, that's something complicated. So you need to design your error handling mechanisms differently. What categories of errors do your application have, and how do you handle them? So you can design your error responses usual way. You keep the errors in the response itself. So you either respond with the data, or you have some error field there that is filled with your errors. Or if you categorize the errors and act accordingly, you can distinguish what is like 500 errors. I couldn't be prepared for this, so I return it in some general error way. Or like user not found or not accessible, I can probably prepare for that and design that error response directly into my schema. Yeah, can include those types into schema. I have an example for this, so we can imagine better. So one thing would be like internal server error. Okay, when I'm in the HTTP protocol, I can return 500, but when I go through the WebSockets, it's a little bit more complicated. So maybe I could design like general graphical errors. So when I have the data, I can return like data there and my data, but when I have the errors, I can return some error array and do some proper response there. Like the GraphQL frameworks that deal with this usually do something like this. So that's fine. I can see what happened there, some unexpected error. but I can also design on expected errors. For example, when I have a user, I can either return the user or user is somehow suspended or blocked. And I can design that to my schema so I can, when I receive that the user is suspended, I have like the response with the reason and I don't need to go to the error domain at all. So that's something to again think about when you designing your schema and think about error handling in advance. Like usually unexpected errors, they are unexpected, so you treat them in some general way. But for the expected ones, you can prepare directly in your schema and let your users know. You know, when the client asks for this, he basically automatically counts for all the states that user can be in and are expected and treated as such. So that's a good thing. Okay, and now when we have our schema, everything handled, changes come, you know, changes always come. So we need a strategy how to handle changes. Like the best thing is to extend rather than change or remove. It's like the usual one because you can always add more things, but when you want to change them or remove them, you break the clients that are connected to your schema. But in the GraphQL, you can do it like in the smart way when you design your API. Like I was saying, you can design for returning always some like object types, so you can easily extend them. When you need to change something, you can, for example, deprecate the old field, but like leave it there and do the new field that is for the future use, and you can slowly like monitor it and remove it in the future. The monitoring is really a crucial part in there because when you don't want to keep your old things, old deprecated things, how do you know when to remove them? Like you can deprecate them, but how do you know? You monitor it, and when you see like this deprecated field wasn't used in a month, I can probably remove it. But if somebody is still using it, I should maybe tell them, hey, like you should stop using this because I want to remove it. You know? So there's basically like you need to like think of the strategy how to handle your future changes. And of course, there's always think about versioning your API, like we do in the REST. Like you can do V1, V2, and so on in the URL. You can do this similar thing with GraphQL. Like nobody can stop you if you do V1/GraphQL, V2/GraphQL, and you can have like completely different schema. But like I said, in the GraphQL, it's like designed to be extended and can be done quite easily. So you are not forced to version the API. But for example, if you have some future changes that like break everything, you can also like version your API. Yeah, and how do you do that? It's quite easy. Usually you have some deprecated like directive annotation there, so you can even say like the reason for the deprecation, and then you have tools. For example, in Node ecosystem, a very popular Apollo server, so you can like monitor how many times which field hit and you know basically. So that's it for me. I hope this helps you in your future path to the GraphQL. It's really interesting and like I would say life-easing technology. And when you think of those challenges ahead, you will have really nice time using it. So thank you for your attention, and you can ask questions now.
I really like the part with the GraphQL. Do you usually design your to be like returning the path and the error, or you keep it just for
Like the very part, we try to like it's. Oh, sorry. Yeah, we try to like it depends from project to project, but nowadays like for example this this knowledge was shared like recently on our Slack, and we like some project already use it. So it depends. Not like we work with the GraphQL for some time here, so not I cannot say like every project has this, but we try. Yep. Yeah.
And
Okay.
the second one, do you miss kind of missing feature in GraphQL is union type for inputs?
Yeah, I missed it very much. Yeah. I think there's a proposal for that already, but it's not approved. So it's in some stage. I don't know. Yeah, I like came across several cases when I would really like that feature, but
How did you solve it?
yeah, basically like duplicate stuff and like have two queries with different inputs or something like that. Okay.
I wonder if it's STRV or you personally, if you prefer the schema first or the code first approach, and why?
Okay. Again, I cannot speak for whole STRV, but I personally prefer the schema first approach because we can easily cooperate with our front-end guys. We can like decide on the schema beforehand. We can then like move the data, and they can start developing while we deal with the backend code. So yeah, basically the schema is like our center point for everything. Yeah.
And do you use subscriptions on production?
Yes, but again, depends on the project. But I really like to use subscription, and it's like convenient because like GraphQL was built for this thing. So yeah, I think it's good to combine not only the HTTP protocol but web skills as well.
How do you handle file uploads?
File uploads are a really funny part. Basically, two solutions for that. One is to have separate REST endpoint and you can upload the binary data. But the new implementation in Upload Server has some like extension for, or even the old one, it was built in, I think. Now the new one is like external plugin for handling file upload. It basically encodes the file some string and uploads them and decodes them. So yeah. So you can find it on the Apple server page. There's a section for file uploads. Okay. I guess that's it. Thank you again. I hope you.
Okay, so now we will have 10 minutes pause. You can find toilets in the back, beer is in the middle, food is next to a beer, smoking downstairs, this is forbidden by firefighters, I think. And see you in 10 minutes then. We are about to continue. Okay, now we are about to continue. Please find your seat. Okay, so next speaker will be Rostislav Klein from Pipedrive, and he will be speaking about their experience with integrating Facebook Messenger API.
Oh, I'll live with that. I'm not able to make it full screen. Never mind. Thank you everyone for coming. So let me briefly introduce myself. Can I have the clicker? Oh, here it is. I'm Rostislav Klein, for short Rostia, from Pipedrive. I've been working for Pipedrive for almost 3 years now, and so far I'm loving it. We spent a couple of last months on implementing Facebook Messenger API into our app. I'll explain later what that means. And along the way, we had some obstacles to go away, like some pitfalls, dead ends, but at the end we still managed to make it working. So let me share some of the main points there. Just to start briefly, who of you have done something like tutorials? Like usually when you would like to try WebSockets for the first time, you would do something like that. Anyone? Please raise hands. Yeah, okay, a couple of people. Yeah, usually it is a simple thing. You just have some server, there's WebSockets, you push a message, you receive it, that's it. But it would be a nice thing to make a startup of, right? But that's not the real world. What we did, Pipedrive is a CRM platform. We have customers who not only send emails to their clients, but nowadays they would also like to message them and perhaps use the most popular platform out there, which is Facebook. Facebook Messenger, I guess most of you here use it. That's also a business version of it. That's what I'm talking about, but you as the end customer, you don't even realize that you're on the business one. You're still messaging someone, but you're messaging a page. You're not messaging your friend, but you're messaging a page. Interesting thing is that we have a marketplace in Pipedrive. Anyone can do integration in Pipedrive, and the same goes for Facebook. You've mostly seen some Facebook that integrate some apps that integrate something into Facebook. So what we are doing is the plus here. We're doing an integration between Pipedrive and the messenger itself, which has a lot of token handling here and there through the marketplaces and all out. But I won't be talking about that. That was pretty much like you have nice Facebook documentation. Both Pipedrive has the documentation how to do that. So this is how our designers imagined it would look like. It's a simple chat app that you've seen mostly in any chat app. So there's the conversation list, there's messages, and the sort of added value that Pipedrive has now is that you can link this conversation to the person that is inside Pipedrive. This you know, Lisa the little you're selling like a new kitchen to this customer, because Pipedrive is used for mostly business to business or some complex sales. It's not like selling you a pair of shoes. So you're doing some complex sales, you're talking to that person, and yeah, you're sending emails to them. It has so that's the stuff that you would like to track in Pipedrive, and then you have some conversation with that person, and perhaps you want to link it. So here it is, and this is the deal. So it's called good deal. You have some. Okay, so our customers actually need it, because nowadays it's not only email. Email is a crucial part, but we try to integrate something like that. In the future, we'll have like WhatsApp and so on, but we started with Facebook as it is the most popular. Okay, let's start with the good things that we encountered along the way. While trying to work with Facebook API, some of you, actually, is there someone with real experience with Facebook? Or at least playing with the Facebook API? Okay. Still a couple of people. Okay, but production experience? Okay, nice. I'm really interested in your ideas. So there's something called Graph API Explorer. There's Facebook has, once again, it has a nice documentation, and then it has some kind of tools. One of it is this great Graph API Explorer. So this way I'm calling endpoint, you can see it, but it's me/conversations. This way I would get all of my conversations. Me, who is me. There's an access token which belongs to page. This is a page. That's also a thing that Facebook gives you. So usually when you're doing an integration, or anytime you have to ask Facebook specifically what kind of permissions you want. So in this case, you need to list the page, list the conversation, and so on and so on. It gives you the token. That thing you need to do in the production as well, but it simplifies the solution a lot. So here I'm getting the conversation actually. And the funny thing is that here it says fields, the query parameter field. So coming to the previous talk, this acts a bit like GraphQL actually, because in the query parameter, you're specifying which fields you want, and then it gives you actually the fields. Surprise! So also it was kind of interesting that the original author of GraphQL is Facebook, and they are not exposing GraphQL. even for their products, which I don't know the reason why, but maybe someone knows. Good thing is that you have something like search for field here, so you can look, it will tell you, hey, this conversation has this kind of field, you can try to test it, use it, then even subfields, so even for this is data about sender, and I want an ID and link, you could specify what kind of data you want for senders. Sorry for interruption. Yeah. Then webhooks. So crucial part of messaging is actually sending and receiving the message. When you're sending it, you're making a REST API call. When you're receiving the message, you're receiving a webhook, which is just the API call which Facebook makes to your API. That works pretty well. So let's imagine there's a page admin, just this one. So this is me who owns the page, and this is the end user, someone who wants to buy something from me. He sends a message, so actually it goes this way. We receive the webhook, we will create the message, send the WebSocket to our client, and that's it. But the thing is that behind there could be your colleague actually, and the page who also, like, there's two salespeople actually making sales with that person, and he answers something on his desktop. This one answers something from the phone. What happens is that the message gets to the user. It gets to the user even from the desktop, but it doesn't go through here. So I don't know what my colleague sent to this person. To rescue Facebook, this is a good thing about Facebook. I'm not sure that every messenger out there has this. It's called Echo. What do you think Echo is? It's like an echo. So I send a message, and anytime I send a message, I receive the webhook as well. So you just need to subscribe to that Echo, and anytime your colleague or even you, even if you send a message, you will receive that webhook. So you gotta make sure if you're sending the message from the first REST API, then it comes back, that you don't save the message twice. So it's actually simple because the message has an ID which comes back from the first REST API call. So you just make sure that you don't duplicate the data there with simple SQL constraints. So then all the messages sent from Pipedrive, or who knows, I can still use the messenger on my phone, or my colleague, anyone, and all the messages that are being sent are actually received by Pipedrive and we're displaying the current state. Yeah, so then it goes even this way. So not only what the end user sends, but also what my colleague sends to that person. Okay, so that was for the good, and then the bad. I'm not saying that this is set in stone. There's definitely some things that we might have misunderstood, but like Facebook is a tech giant, so one would think that the API is perfect, but we found some problems. Yeah, so here's very oversimplified data model. We have conversation, message, and sender. Conversation can have multiple messages. Sender might have multiple messages as well, which means it is linked to it. So then, in the end, there could be multiple senders in that conversation, right? That's called group chat, right? Problem is, when Facebook sends that webhook that I was talking about, it looks like something like this, and there's no information whatsoever about the conversation itself. So there's an info about sender, there's info about the recipient. It tells you who sent the message for whom. This will be always this sender entity, that's the person, but you don't know which conversation it belongs to. We tried to dig deep a bit. Seems like it was there at some point, but Facebook then dropped it. I guess the reason might be that in the business Facebook business messenger, you can't have group chats. But Facebook still has something like conversation entity. They still count with something like conversation, or it is called conversation, but actually you won't receive it in the webhook, so you don't know where to put the message to. Well, the solution was you can actually call Facebook and ask, hey, where does this sender belong to? Which conversation does it belong to? So Facebook tells you, hey, this is the conversation. Don't ask me why. The problem is that Facebook has rate limits. So imagine doing that call for every single message. That won't scale much. Solution was pretty simple. We introduced Redis in between. So anytime you ask, hey, what is the conversation this sender belongs to? There's this circumstance that one sender can't belong to multiple conversations. So we always know it is that conversation, so then it goes there. But still, our data model is kind of prepared for the next integration that is to come, which is WhatsApp, and they do support group messages. Next thing, and that's mostly product-wise, is a bit of enforced behavior. I don't know, maybe I'm standing some. But okay, it's enforced behavior. So Facebook kind of limits what you can do. This is how the business Facebook Messenger looks like. This is actually a real screenshot, so there's somewhat. Never mind. Thing is that you can reply to this conversation anytime. From that UI of Facebook, I come here. This is my profile on Facebook. I can reply anytime I want. When you want to send a message from the UI that you did, or actually any API, because this is an integration, as you can see, the UI looks pretty much the same. You are limited to 24 hours or 7 days if you apply for a thing called human agent tag. I mean, I can see the reasoning behind it. Facebook wants pages to reply as soon as possible, so there's these 24 hours. And most of the apps that are being built in Facebook are automations. So I don't know, like you buy something, and then it gives you back the message, hey, your order is ready, come pick it up. But in our case, it's actually just rebuilding the UI. We don't want anything else. And still, we have to limit our users. And actually, you have to go through app review. And only after the app review, you'll be able to apply for the human agent tag. That kind of sucks. And now for the ugly, it's bad. It's bad, both bad, and I'm not really happy about the solutions. But we still made it working. So we use TypeScript at backend. It's not just TypeScript. Is there anyone who uses Node.js without TypeScript? Please raise your hands. I won't judge. Okay, there's a hand. Two. Okay, I guess nobody else uses Node.js. And we're heavily TypeScript based. We have, I don't think even in Prague we have any service written in JavaScript. The problem is that when you're calling Facebook, they have a nice documentation, but they have no OpenIM specification. So this is the Swagger thing you see there, here and there. So you have to assume the types. Okay, it says in documentation that there's an ID. Okay, so the ID is there, right? Coming again to the webhook type that we've seen, this would be pretty much the type for it, as I would do it myself in the TypeScript itself. But okay, this is a oversimplified function. Says process event. For some reason, it comes as a string. So we will parse the string, and then what? This parses it, and this would be, I guess, unknown in TypeScript, or maybe object. Don't take me. So you would typecast it, and you would say, hey, I know that this because body for this event is always this kind of type. That might work. And then you will receive errors like, hey, cannot reach property ID of undefined because there was undefined for whatever reason. You assume that the sender is ID string, but yeah. Maybe important to mention, the webhook has a generic endpoint, and you can send anything to that, and you have to process it. There's multiple webhooks. There's not just some message. There's like updated and whatnot. But you don't care about those, you care about those who do respond to the message. How we solved it? So, sort of type assurance, I like to call it. We, for example, use a library called runtypes. you will define the type, and actually in the runtime, it makes sure the type matches whatever you are assuming. So this is the type, messaging, that's the object. So you can type anything that you could, or actually you can compose anything that you could type in TypeScript with runtypes. So actually then you just call rt static type of, and the webhook event type is the very same thing that I showed you, which I did myself previously, that I assume that the type looks like this. So in the code then, what I would do is, what I would do is get the request body and actually still parse it with the JSON and use that variable that I defined from the runtypes to check that it really is what I'm assuming it is. The solution, the best solution for this would be to have a GraphQL or the OpenAPI and actually to generate the types out of it, but we don't have that. And then you can decide your logic. Like in this case, we would throw, hey, I don't know this, I don't know what to do with such error, with such payload, and then throw early, not somewhere in the code saying, hey, cannot read the property ID undefined. And then you can decide there. So that was for the type. Next thing is sending a message. I'll try to be quick. So you want to send a message, right? This is some curl request that you send, message, text, send it, it works. Then you want to send just an attachment, because people might want to send the message without attachment. So with form data, you append the file data somewhat, then you get the message. Yeah, there's no text. I send it, it sends the attachment. Okay, what about sending both? Because some people might want to send an attachment with the message, right? It's still a valid use case. Let's check the documentation. It says you may also use the send API to simultaneously send a message with an attachment. Okay, let's try it out. Maybe you might guess it doesn't work. The only thing it doesn't actually sends the text for some unknown reason. Well, the fix was simple. We first send the attachment on the backend. When we see there's both, we would actually do requests to Facebook, first with the attachment, then with the text itself. We could flip it, but it's just a bit quick. And the last ugly thing that we found out that was the most worrying part was pagination through sync data. So imagine I have a UI like this, and what we do is that we don't download all the data, because you might have like thousands of messages with someone in some conversation that you actually might never want to open. So we download first 30 conversation and first 30 messages from Facebook. And then when the user scrolls, we would actually ask Facebook, hey, do you have some more messages with that person? So Facebook actually offers 3 types of pagination that that's two more than we need. What about the offset base? Well, for those of you who know how offset works, is that you specify the offset and then the limit. So the offset would be 0, then limit 10, then offset 10, limit 10. So we would get the 10, the first 20. But it's a problem when you're using actually the messages, because you send a new message, it's appended to the start of the list. Then you ask for the next 20, and it's actually off one message. So that doesn't work with messages. The time-based one. So you have 20 first messages, which you did with the first thing, and then you say, hey, this is the last message. Give me everything that is after this timestamp. For some unknown reason, it doesn't work for messages. In the Graph API, we tried every single possible way. It didn't work. Maybe we're mistaken there. So what's left? There's this cursor base, but for those of you who don't know what cursor is, it's a pointer to somewhere in the list, and it should be unique to that list. So say, hey, I want everything after that cursor. Give me. The problem is that the cursor is not persisted, so might happen that someone deletes the message, and then the cursor is invalid because there's not this item in the list, and yeah. But yeah, I mean, what's there left to do. So what we did is that when we were thinking the first 20 messages from Facebook, we saved the cursor. We actually save it, and then when the user scrolls up the conversation, we push more, I don't know, there's the limit, like 30, and we save the next cursor. So we actually know what's the latest cursor from Facebook data. Anytime user scrolls through these, we don't do the request to Facebook because we already have that data. But when you do it for the first time, you have to do it. The problem with the invalid cursor is a bit solvable. If you use an invalid cursor, it would go to the start of the list. So what we would do, we would loop until there's a message that we haven't seen yet and hope that it would work. Okay, so just to sum it up, there were nice things, there were some bad things, of course, and I really think from either our side or Facebook side, I'm still not convinced that all of that is a Facebook problem, but actually the outcome might be that the perfect API doesn't exist, even tech giants like Facebook are struggling, or might be that we are not the right consumer, or we're thinking bad about it. So even though we strive for our best public API to our customers, it might not suit their needs. And the other thing which we do a lot nowadays in Pipedrive is actually to check your types coming from external systems. External system means basically anything that goes out of your repo that you can't be sure. Sometimes we do even run types for database queries. Someone might come and delete a column, then you assume the column is there. And even like through internal services, we have a lot of internal services talking to each other, and it's not public API, nobody cares about documenting it. So better make sure that it actually exists. That was it. Thank you. And now, of course, open for questions. Any? There's some pros with implementing Facebook, so I'm looking for. Maybe you can help us actually.
7 years ago, they didn't even have that GraphQL because it wasn't like.
I can see well, but I still can't
Maybe
see.
I have one question.
Yeah, cool.
You mentioned that the group conversations are possible or are not possible.
Yeah, the question was whether group conversations are or are not possible. They are not possible in the because when you're talking with Facebook page, you can't invite Facebook page to a group chat in Facebook. I haven't seen that. I don't think that's technically possible. So there's this hard limit, but as I said, Facebook is just the first integration, but our customers actually in Brazil, they use WhatsApp a lot, much more than Facebook Messenger. So we wanted to be ready for that, and WhatsApp actually supports group chats. So that was one of the reasons why we chose such a model. But it might happen that Facebook might support group chats. I don't know what would it do actually with our current architecture. I guess we would need to change it. Anyone else out there? You know, it's kind of late already. Everyone's hungry or thirsty. Okay, that was it. Then thank you, everyone.
Okay, thank you again. So now we can move to our last speaker, Erhart from STRV, who will show you some tips and tricks about scaffolding Node.js applications. Maybe with live coding. Enjoy.
Hello? Hello? Okay, so this works. Nice. I know all of you are kind of looking to have some more beers and more fun, so I'll try to keep it short. Nice to meet you all. I'm Irka, and let's get right into it. So first of all, I said scaffolding. Now, what does that mean in this case? So basically, when you're tasked with the task of starting a new project, you'll need to set it all up from the beginning. Now, unfortunately, this is different discipline from what we're used to in day-to-day development, because the things that need to be set up are usually there set up for us, and we just use them and are happy about them. Now, maybe just a quick question, show of hands. How many of you have ever started a project in Node.js from scratch? Okay, so all of you already know the pain, and the rest of you, you'll just have to take my word for it. So usually when we start the project here, we would like basically all of these things to be set up for us so that we can then just use them and don't worry about them. Unfortunately, when it comes to Node is modular. Modular in a way that basically any of these you need to take care of it yourself using special packages. And setting all of this up is kind of a time-consuming and maybe frustrating process. So let's see what we can do about it. So the term used here is project scaffolding. It's basically making sure that we have some good thing to start with. And the good things about it, it mainly saves us time, hours or even days at the beginning for maybe less senior people. It provides some same defaults that they can just rely on without the need to understand everything from the start. And also it usually provides us with a tested code that we can just take and then move on without need to focus our energy on it. But it might be in the modular ecosystem as Node.js is to find the right template for our needs. And also the scaffolding part might have a slight learning curve. So let's see what are our options. Well, the first and obvious one, this one is mainly for labs, is npm init or yarn init. You all know them, but this is basically all that it will give you. Basic package JSON, and that's it. There's not much help in that. So, well, the next thing when someone first starts a new project or start, well, what they usually do is they look at the project they were working previously and just copy paste. Well, this process is good for understanding how things tie together, and I wouldn't disregard it completely. But let's say doing this once is enough, and afterwards, well, you would probably want something better. So the next thing is, well, when you've gone through the process, taking the current parts of a project from an existing one, well, maybe you want to save that for later. So you can use it again when you need to bootstrap something from the start again. Now, this approach is very simple. We just store it in a separate Git repository. The nice part about it is that we can store exactly what we like about the setup there. And it's also what we do here. Basically, in an agency where we have a lot of projects, a lot of people with opinions. It's nice to have some ground template that everyone can start from and understand. The main drawbacks of this approach would be, oh, first of all, someone has to set it up. But fortunately, there's always someone motivated to do so. But then, unfortunately, the JavaScript ecosystem moves fast enough that in half a year, template that hasn't been attended to has a lot of packages out of date that when you update those, you might run into serious issues. So then what usually happens when someone new comes, they need to start a project, the first thing they do is
fix the template, and they use it. Also, this gives us some flexibility where if someone doesn't like a particular part of it, they can just switch it for something else on their project and don't have to take it all as one piece. And then there's also the part where, well, this template is useful in the beginning, but then any updates to it can't really translate to the running project, because that would mean that all of the updates need to be backwards compatible, which would again stifle the evolvement of the template. So basically, you take what's there at the moment, and then you just roll with it without any future updates. So that's that. It's also a fairly simple approach, and anyone who comes can just git clone, and they've got something that the rest of the company knows how to work with. So in that regard, it's very very nice to have. So, but maybe we can take another approach. So many of you probably seen these. Each backend framework has one of these, a basic generator that can generate basically a simple project template for the framework. And these are really easy to use. Basically, this is how you would install any of these. With the simpler ones, you just execute the package and it creates a project template for you. But also, these are usually kind of simple. So sometimes you get tests, sometimes you don't. Sometimes you get to choose TypeScript, sometimes you don't. Usually you don't get any documentation and stuff like that. Maybe the most advanced of these would be the Node.js CLI one, which we can maybe see later. So that's for the framework generators. Also, this is kind of, if you use these, you kind of depend on whoever maintains the project. So if they in the future just change their mind, then the next time you might not be able to use it so easily. And for those who aren't happy with the previous ones, basically there's Yeoman, which is generator. Basically a package that allows you to either create generators or then apply them. The nice part about this is that it has a huge library of different generators that are ready for you to use, and you just call yo and what you want, maybe yo feathers, and it would give you a basic project setup for that kind of framework. Well, there is a wide variety of these, so it also means that there's a lot of opinions how basic Node projects should be set up like. From the ones that are worth mentioning and worth looking into, I found those two, generator Hipster.js and generator feathers. Then the audience for the other packages kind of dies out, so it then again might be worth considering whether it's worth to use that in one of the projects, because the support for these might go away quite soon. So that's with the generators, and these are usually fairly good when you want to start the project, but maybe then you've got a running project and you want something that will help you code in that project. So, for example, let's say we have a route. Well, we would have a certain number of steps. I would program a
REST API route, like a get one or post one. It might involve touching 3 or 4 files, some for maybe parsing, some for the row definition, some for the actual business logic. And with these, they might have a common set of boilerplate code that one would just type over again and again and again. Now, if you have these, then it might be nice to automate the generation of this boilerplate code. Basically for 2 reasons: to save you a little bit of time when creating these, and also it might help onboarding people on your project. For them to just have the ability to generate this boilerplate might help them to understand how you structure code and how these common additions to the code base would be implemented. And that's what Hygiene is for. It has over 110,000 weekly downloads on NPM, so it's not something rare. It's fairly used in the community and might be worth implementing in one of your projects. And well, I cannot say you tell you much more. There are probably some projects worth mentioning that I overlooked when doing research for this. I'd be happy to hear something about that, maybe then over some beers. But what I thought might be useful here is if I would show you how to use Yeoman and Hygiene live, so you can then see whether it's simple enough for you to use on your project. So this is going to be an experiment, but can you hear me? Yaraj? Okay. Okay, so let's go right into it. So basically what I wanted to show you is how you generate a basic feathers application and then use Hygiene to maybe create a template in it. Well, this is probably does this look good even from the back? Okay, cool. So I've got an empty folder here. And I will start with generating the feather set. And for that, I already installed Yeoman. Well, I'm going to show you what I did because that took a long time. So I have globally installed. So I cannot speak and code at the same time. I should have thought about that. Yeoman and also generate feathers. Stay. So this I already executed. It took some time to install, but now it's all there. Let's then see how we can generate the feather set. So you just go feathers, and this should give us an error. So, well, I understand most of you like TypeScript, so let's use TypeScript. Then we just choose the project name. Let's say just test with description. Also easy. I think our source files can live in the source folder, so just confirm that. Then I personally still use NPM. Maybe I'm the last one, but anyway, you have the choice if you're going to go through this on your own later. Okay. You should hear me better now. I'm sorry. So now I think we can keep both REST and socket.io. So let's just go with that. I like Jest a little better. And let's say, yeah, we want to write an application that manages users and their authentication. So just go with yes. Then we can choose what kind of authentication we would like. Well, for all of you here, maybe let's just go with GitHub and be done with it. And okay, then what's the name of the users entity? For us, it would be just users. And here for the demonstrations, I'll just use SQLite as a controversial ORM and SQLite just so we can run the code right away. Okay, and then it creates the basic project structure for us. It might take a little bit of time. So, well, basically how this is gonna go, I'm gonna show you this, then it's gonna be time for questions, and then we're all gonna have some nice beers. So while we're waiting for this to finish, are there any questions? There might be done. It's fairly simple topic. Anyone can just find on the internet. I thought it would be nice for you to see. Okay, or there.
How painful it is to actually like update the code scaffolding? Like you have this in a Git repository, I guess, or you want to scaffold the project and you know beforehand that there's something different. And you're like, hey, I would like to use this, but yeah, there's this one file that's different than what it will generate. And it's going to be different for the future. So how painful it is to update this? Or how often do you do this?
Well, to be completely honest, the rate at which we go on new projects here would be maybe once or twice a year. So with this rate, I'm fairly okay with just using a generator that's close to what I would like, and then just editing the files that it generates to my liking. If one were to automate it, that's a completely different question. But unfortunately, one that I don't have to struggle with. Okay, you know, demos, they always take more time than they should. Still, space for questions, if anyone would like. Okay, we're getting close. Okay, so it did generate something for us. Let's see what that is. So this would be the project structure. For this particle generator, there are more advanced one, like the JHipster one, which basically generates Java application in TypeScript for you. But it has some very nice feature like even code quality checker and stuff like that. Something that if one were to start from scratch on their own, they would probably not implement until much later. So this would be what it generates for us for the Feathers app. Maybe what might be relevant here is to check the package JSON for the dependencies that it uses. It basically uses a lot from the Feathers framework because that one is fairly modular, and then a few the dependencies that might be a good start for us. And then it also adds some basic structure, also with services for the users for their authentication and management. which is nice. We don't have to code it ourselves. We maybe just need to check whether it's up to what we would like. So this is the generated project. Now there's usually a README which would tell you what you have to do next. In this case, you just npm install, but that already happened for us, and then just npm start, and we would have a running app. So that would be about Yaman and one of the generators available there. Let me show you one more thing, and it would be Hygen. So before we do so, let me just init a repository here so that we can then see the different files that Hygen generated. Currently, all of it is not added, so let's just git add and git commit. Maybe. Okay. Well, it's always good to sign your commits. That's what has been happening here. Now we have nothing in the working copy, so let's init Hygen for our project. That would, well, you would either install Hygen globally, or it would be one of your dev dependencies, and then you would just use it that way. For the sake of easiness, here I just installed it globally. And what we need is generator, new one, and the generator we would do, let's call it service generator. Okay, this initiated. Okay, my apologies. First, we need to init Hygen in the project. This would add some underscore template directory to our projects where all our templates will live in the future. And it adds some basic generator functions that we can then use to generate our generators. Sounds complicated, but it really isn't. The usage then is that we would just Hygen generator new and give it the name of our generator. Let's call it service. And this edit one more file in templates directory. Service is the name of our generator. New is the default action, and hello is then the file that it would use to execute or basically process when we run the generator. So now we generated the generator. Let's edit it. So let's see our service new hello. This is a basic template that it created for us. Now the template we can modify. It's something that we generated earlier when we initiated Hygen. So this, what you see as the first thing, can be something completely different that is adjusted to your liking. So what we do here, what we would do here is maybe say what file should be created when the service new generator is run. For us, let's say it would create a file in the source services directory. And let's call the file by the name that we give to the generator. And just for the sake of the demonstration, let's call it our new service file, which should generate a file with the name, with this content. Now we can make this much more dynamic. but that's out of the scope of this presentation. Let's just see how it would be used, because these templates, they do live in your project and are specific to your project. So the idea there is whenever someone sees that there could be a generator used for some part of code that is repeated over and over again, then they would just create it for the others, check into the code base, and others can then easily use it. So next thing, for us to see that it really generated something, let me just add everything and commit it. Let's say Gen init. And now what we would do is just say, now the working copy is clear. Hygen service new, and then we would name our service. So let's just call it for the sake of demonstration. And it then just tells us what it did. It added a file to source services hi.js with the content that we specify. Now, the content would be the scaffolding for how your services look like. It's not just a comment, but that's how easy it would be to introduce this into your project and then also use it in the team. Okay, this is basically all that I wanted to show you. Are there any questions after this? Okay, if not, there's no point in taking this any further. That's been all for me, and let's enjoy the party.